Welcome, everyone, to another Silicon Labs product podcast. I'm excited, Mike Dow. He was on a previous podcast, so I'm glad that he's come back. We have a lot more topics as far as security is concerned, so we're going to touch on a few of those in today's episode. Just a reminder that Mike is the Senior Product Manager for the IoT security solutions at Silicon Labs. And as we learned in the last episode, that means that Mike really knows his stuff about security. So thanks, Mike, for coming today.
Glad to be here, Kyle.
So as I mentioned, we're going to talk a little bit. We just did public announcement on our XG21B and production availability for those parts. And so there's a few new features released with that. And so that's really the focus of today's podcast. But before that, we finished the WorksWith event, and you had a session called Security Regulations, and I was able to watch it. And it's a good 60-minute session. And in that, you covered a lot of the topics we're going to talk about today, but then you expanded on a lot of the necessity, the requirements. So I thought you did a terrific job. Thanks for doing that episode. Yeah, we had over 2,000 guests. So anyone that's listening to this podcast, I'll put the link in the podcast notes, and you guys can watch that security regulations in its entirety. Before we jump into the features of the XG21B, I thought it was really interesting. You had shared that recently there's been a lot of security regulations, different agencies that are working on defining how security is introduced in the IoT. Can you talk about some of those agencies?
So the really major things are happening. Requirements are being defined. So there's actually a bill that got introduced actually passed the House this week. That is an IoT security bill. That's news. It was actually news this week for me. That's basically looking at procurement for the government. So if you think about all the things the government buys, if this bill makes it through the Senate, it will actually start regulating things that the government purchases. And that can be lighting control systems in a building. It can be fire alarm systems in a building. There's a lot of things in building control that, of course, the federal government is one of the largest owners of buildings in the world. They're going to be looking at NIST standards. So NIST standards were one of the things that I pointed out. There's now two documents. There's 8259, which talks about recommendations for manufacturers, and then there's 8259A, which is actually a list of baseline requirements for devices. So that's one. That's really covering the U.S. And then in Europe, ENISA has the authority from the European Union to address requirements, and they haven't really selected any yet. But there's an organization called ETSI, which has come out with EN 303645, and that looks like the front runner for defining IoT security requirements.
So I didn't know that, but the House putting forward that bill, that's really putting this in front of a lot of our customers now. So they have to start looking at that or in those requirements. Can you touch on a couple of the things that are really consistent in those definitions that the NIST and the ENISA are putting out?
So all of them talk about using standardized cryptography, right? So recognized standardized cryptography. That means don't come up with your own crypto algorithms. You need to have, and really these are NIST algorithms, at least for the US and the EU. NIST basically approves security algorithms, both symmetric and asymmetric. So that's one of the common themes, is that you shouldn't use cryptography that is something you just made up because it's too easy. It hasn't been vetted. The idea is that cryptography, everybody knows the algorithm, and the reason for that is that you want everybody to try to break it. And the whole point of all this vetting is to make sure that you have very strong cryptography. So if you roll your own cryptography, chances you getting it right are pretty slim. So that's one common thing. The other thing is authenticate the code that you're going to run. So in our world, that's like a secure boot process. They also are talking about over-the-air updates or being able to update the software. So both those ETSI and NIST requirements talk about OTA, and they talk about securing device interfaces. And the easiest device interface to get into a part is the debug interface. So that's where secure debug would come into play for us. Cryptography, secure debug, all of those security functions I just mentioned rely heavily on keys, because keys are the foundational support for all cryptography, and cryptography is the foundation for all your security. So key management becomes very important as well.
And that's a great lead in. So we're going to talk about the new features that SecureVault is now adding with these XG21B parts. And the first one, I think you just touched on it, is you talked about key requirements and secure data. Can you share some of these new features now that customers can evaluate and get out of the Secure Vault?
Yeah, so one of the main features SecureVault adds is key management. So we do that with a method called key blobs, where you encrypt the key material. And that gives you a very flexible way of keeping key material. It's only limited by the amount of flash and RAM and ROM you have, which is good. The weakness of that particular scheme is that you have to have one symmetric key that is the key to all the kingdom, right? It's the symmetric key that does that wrapping of those key materials. And so you have to make sure that's very secure. So we use the physically unclonable function in SecureVault to basically create a seed key and pipe that directly into the AES engine. And only the AES engine can see that key. And that seed key gets used to create that symmetric key. So that particular key doesn't stay around when the part is powered down. It gets recreated every time that the part is powered up. We also have tamper capability on that, where this is an additional function that you get with SecureVault. But tamper can trigger what we call the nuclear option on the puff, which is to destroy the reconstruction data, which basically means that seed key can't reconstruct it, which means that symmetric key can't reconstruct it, which basically means all that data you might have stored off encrypted in the system is now just useless ones and zeros. It also breaks the boot process because we wrap the boot keys that are necessary for secure boot with that wrapping function as well. And so now the part won't boot. So this we call the bricking option, right? So that's why it's called the nuclear bomb option is you pull that trigger, the part will not boot, and all of the key material will be useless to anybody trying to hack the device.
So that kind of reminds me, I mentioned it reminds me of the Get Smart show that we used to watch when we were kids. You know, they had all those fancy gizmos, and he'd get his message and then it would self-destruct.
Oh
So
yeah, I was trying to think about what you meant by that.
yeah, so anti-tamper. So what are some of the other things other than destroying the key? What are some of the other anti-tamper things inside of the anti-tamper capabilities of our part?
Yeah, we have. I think the easiest one for people to understand is just putting a contact switch on the case. So if you don't want somebody to get a hold of your device, let's say you have a device that's in the wild, maybe it's a smart city device, a parking meter, or it's a Best Buy device, it's a consumer device where anybody can go buy it, or it's pretty easy to get in the supply chain, like almost anybody can buy it from Amazon. If they can get their hands on it, there's a lot more attacks that people can do with the device. These are called local attacks. And the easiest thing to do is put a tamper switch on the case so that if the case is opened, you basically do that nuclear option. So you could basically brick the device if the case is ever opened. That pretty much rules out a ton of physical attacks. But doing that sometimes takes a little bit of mechanical know-how, and some of these can be a little tricky and finicky. So uh, and they can be bypassed. It's not impossible to get past these. So we have other tamper mechanisms like another. So let's say they get past the case and they want to start doing some simple voltage glitching. So we have a voltage monitor, glitch monitor. We have temperature. That's the other common thing is you freeze the part and try to do something from a temperature perspective. So voltage, temperature. We also have there's digital glitching that you can do, and we have some detectors on that. So we have various other tamper sources. We have some that are looking at the secure core element and making sure that that's its integrity. It runs an integrity check every so often, and if that ever gets violated. So we have a lot of different tamper sources in addition to just a simple GPIO coming in for a tamper switch, which can do various things. You can cause a reset of the device. You can cause an interrupt where you can actually do some execution of code and maybe do some further investigation on the tamper before you decide to tamper. And then we have the nuclear option, which basically is to destroy the reconstruction data. And there's also some debounce filtering on all of that as well that you can do.
Sure, that's great. Great new features. I'm sure people that are looking at security, that is top of the list. So the last thing I wanted you to touch on, and again, it was brought to my attention from your presentation during WorksWith. You mentioned the chip birth certificate, and I know when we talked, you said that your favorite new feature in our Secure Vault capabilities is the secure attestation. Can you tell the listeners about the ability and why it's so important?
Yeah, so this is I think is going to be a super important thing moving forward because with these IoT and industrial IoT systems. They're basically ecosystems. So all these big guys are trying to create the biggest ecosystem for their particular players. So even in the industrial IoT world, Siemens or Schneider are trying to create their Siemens ecosystem or their Schneider ecosystem. And they want to have lots of people creating devices for their ecosystems. And of course, you've got the Amazon ecosystem and you've got Apple ecosystem. And so, but the problem with that is that you've got a lot of devices that you can't really trust. You got so many devices that are trying to join your network, and you try to do the best job you can of making sure that you put all kinds of requirements on the device and so forth. But even if it was manufactured properly, it could be hacked, like we talked about. It could be hacked, and you could create a clone device, or you might have gray market devices, and so you could easily get bad actors on your system. So device attestation is really the notion that through cryptography, I'm going to do a request response to the device and have it give me a birth certificate, which basically I can say, yep, I know where it was manufactured. And in that birth certificate is going to be a public key. And that public key is bound to the certificate. And if you have a private key in the device that matches that public key, you can send it what's called a nonce, which is basically just a random number, have that signed and passed back to you, and you can verify with that public key that the device still has that private key, which matches that birth certificate. So it's a very secure way of saying, yes, that device has that private key that nobody else should have. And as long as you protect that private key, which goes back to key management again, then you have an authenticated device. Now, what we do in Silicon Labs is we're the first company to come out with a factory programmed device identity on a mass production scale. I've worked for other companies, and certainly there are services that other companies offer, but they're typically services to get this identity into the device. We are offering this at least silicon level device identity as part of the SecureVault. So you get a SecureVault part, you have that secure identity, and you can at least make sure that the identity of the silicon in the device has not changed. You can know that it's an authentic piece of silicon from Labs, no questions. If you want to do further things like tie that to your device level identity, then we can work with you on custom programming service to basically tie our certificate chain to your certificate chain. And therefore, you can verify that not only the silicon is authentic from Silicon Labs, but the device has been manufactured per your CM without over manufacturing and a bunch of other stuff that you might be worried about in your supply chain. So incredibly powerful way of knowing that devices are good to be on your network. And you can even extrapolate that out to security certificates, right? I'm in IoT Alliance on the board, and we're talking about, well, instead of handing out just a paper certificate saying that you pass this security, what if we did an X509 certificate that basically says you pass the security, and you could actually inquire the device when it tries to join your network? You'd say, please give me your IoT Alliance security certification, let me validate it. And you could go do some validation in the cloud, make sure it's still valid. And let's say it's out of date, right? Or it got kicked out of the program because it was the actor was not a good actor and didn't keep the program current. You don't have to let them join. So very, very powerful thing. Again, why I'm very, very excited about it. I think it's the wave of the future.
That sounds great. Sounds like it's well thought out and something that's definitely needed by our customers. So thanks, Mike. I think these updates you provided, going over those 3 new features of SecureVault, were really helpful for our listeners. Where would you suggest they should go to get additional information on some of these new features?
Silabs.com/security is the best place to go. You should have links to SecureVault there. If you want to look at the parts specifically, they're the XG21B parts that has SecureVault. Not to be confused with the A parts. The A parts have secure elements. So they have a lot of the same things, secure boot and secure debug, but the B parts are what you want to look for with the 3 new features we've talked about today.
Well, that's great. Thanks a lot, Mike. Thanks for joining us again.
All right. Good to be with you again, Kyle.
All right.
Talk to you again soon.
And thanks to our listeners. Appreciate you taking the time to download and listen to our podcast. And stay tuned for new episodes. We'll have Mike back to talk more security, and we'll have some other guests to talk about some of the other new solutions from Silicon Labs. Thanks, everyone, and have a great day.